All right, good morning, everyone. So today we're going to go ahead and talk about some of the properties of water. So let's just start out with the basics. Water is what we call a polar molecule. So that means think of it as almost like a mini magnet. So magnets have a positive and a negative charge, just like water. It's going to have a positive and negative charge on either end. So they can kind of stick together that way. So you have the two positive charges on the hydrogens, so two hydrogen atoms, and then the negative charge on the oxygen atom. So um, two hydrogen, one oxygen. Oxygen is negative, hydrogens are positive. Okay, so that kind of gives it a lot of the properties we're going to talk about today, uh, as opposed to something that's non-polar. So something that's non-polar would not have these charged regions. So something like oil, for example, is nonpolar. So polar and nonpolar molecules do not mix together. So like water and oil, you can throw them in a container, shake it up, it's not going to mix together. It's always going to separate. Okay. And then so those specific terms for the bonds between water molecules, we call those hydrogen bonds. So between the positive hydrogen and the negative oxygen. All right. First property of water we call high specific heat. Sometimes it's called high heat capacity. It could be written either way on your exams. Just keep that in mind. This just means that it takes a lot of energy to increase the temperature of water. So, in other words, water is really good at resisting temperature change, regulating temperature, moderating temperature, however you want to phrase it. And this is really important. So, for example, um, say it's 90 degrees, 90 degrees, 90 degrees, and the temperature of the ocean is like 87 degrees, and all of a sudden a cold front comes in and drops down to 70. Okay, the ocean isn't going to drop to 70 degrees. Okay, it's resist that temperature change. Now, if it's 70 degrees for a long period of time, it'll slowly work its way down, but it's not going to change that quickly. And this is also the reason, like islands, so islands tend to have a really more of a stable temperature because they're surrounded by water. They're surrounded by that stable temperature of the water. So it kind of helps the entire island temperature stay stable as well. All right. All right. Next, cohesion and adhesion. Cohesion is just how particles of the same kinds that stick together. Water will stick to itself, how it kind of forms in the droplets. Um, and then adhesion would be water sticking to other things. So this also gives us what we call surface tension. Surface tension, think of it as like a net on the surface of the water, um, that certain insects and stuff can benefit from this. They can walk on the water. You can take a paper clip. Paper clip will float on the top of the water if you get it just right. You can get it to float. And then cohesion and adhesion work together to give us another property. It's not listed here, but it's called capillary action. So capillary action is how plants are able to move water from the roots up to the leaves of the plant. Okay, so obviously that's really important. That's the type of question you'll have on your exam in terms of capillary action in living things. So that's why that's important. Water is what we call a universal solvent. That just means it's really good at dissolving a lot of things. So so um, solvent would be the water, and then a solute is what's getting dissolved in the water. So if we're talking about dissolving sugar in water, sugar would be the solute, water would be the solvent. And this is important in like the water. Water's, special organisms that living in the water, they can um, important nutrients and salt and stuff will get absorbed into the water, dissolved into the water. This is also important in living things like in your blood. Vitamins, nutrients, and minerals, stuff that you need, can easily dissolve into you through your bloodstream and into your body or any living thing in that. All right. Also, very important. You don't normally think about, but obviously, so water can freeze when it gets cold enough. It freezes. So what water does, if you've ever actually tried to cool down a bottle of water, stuck it in the freezer and forgot about it, it expands and it explodes. So water is going to expand when it freezes. That's because the molecules change shape. They spread out like in this picture right here. So when they do that, that means water becomes less dense, or the ice becomes less dense than the liquid water. And then because it's less dense than liquid water, it's going to float. And of course, this is important because it protects like organisms living in the water, prevents them from freezing to death. So it kind of have that layer on the top, and so the whole thing doesn't just freeze over in one big chunk of ice. All right, and that's it for properties of water. All right, you guys have a great day.